Okay, so let's do a little bit of housekeeping first. You should have turned in the 1.2 homework assignment. If you did not turn in the 1.2 homework assignment, then when you turn it in, hopefully tomorrow or the next day, you will not only fill out this paper and staple it to your homework, but you will also go to Google Classroom under algebra, and in the classwork, the late work form. Okay, you need to fill that out. So if you did not turn in your worksheet today, you're filling out the online form and attaching this pink slip to your homework when you get it turned in. Okay, it will be a 0 in the grade book until it gets fixed. Just throwing that out there. Okay. I will grade that homework that you just gave me, hopefully tonight, but I can't guarantee it. Okay. When I give it back to you, you will have an opportunity to redo problems for full credit back. Okay. Today we're going to go through section 1.3. The start of it's going to look very similar to what we've been doing the past couple days, but we're going to add one more thing, and that's the fact that we could have infinitely many solutions, or we could have no solution to our equation. So that's really the only thing different about today's lesson. We're going to go ahead and review solving equations tomorrow, and your first quiz is on Friday. Okay. Do you have any questions about that? Okay. So I need you to turn to this page. What page is it? 14. Thank you. All right. So we have been solving equations where we have variables maybe on one side, maybe on both sides, but no matter what, we need to make sure we simplify both sides of our equation before we go through the process of like putting x's on one side, non-x's on the other. So let's just remember those 5 steps that I asked you to write down. Now you wrote these down 2 days ago, so you decide whether you need them again. But step 1, I asked you to distribute if that was necessary. Okay. Step 2, I asked you to combine like terms if necessary. Okay. Then I want variables on one side. Constants on another. Once you have variables on one side and constants on the other side, then we can divide by that coefficient in order to isolate our variable. Okay. Jenna, did you find what you were looking for? Did you find what you were looking for? Okay. Okay, so we are going to do some problems that are going to feel very familiar. And then we'll get into what happens if there's like these special solutions right here, okay? So let's go ahead. The next page, they have these steps right here. I want to point out this last one right here, check your solution. You should always know if you have the right answer because you can plug it back in for X and it should be a true statement, okay? So even if the answers aren't posted, you should still know if you have the right answer or not because you can plug it in and you can check, okay? So let's go ahead and start off with number 2 here. We're going to do problem number 2. And what I'd like you to do, I'd like you to look at that problem. and I'd like you to turn to your neighbor and agree on what our first step needs to be. Ready, set, go. All right, eyes back up here. Eyes back up here. Abby, what should our first step be?
We need to find a way to combine the variables.
Okay, so we don't have to worry about, we don't have parentheses to distribute. We don't have combined like terms. We just need to make sure that our variables get put together. Now, some of you may feel very strongly about one side of the equation that the variables should be on. Some of you may feel very strongly about, if I can make my variables positive, I really like that. I'm sort of that second one. I really like variables to be positive. So if I were making the decisions about this, I would want to add 5z to both sides. Are you okay with that? Okay, so I'm going to add 5z to both sides. So I have 7 equals 17 plus 10z. Agree?
Yes.
Okay. Seth, what would our next move be? What number do we need to get rid of? Okay, and how do we get 17 to the other side? Okay, we need to subtract 17 so that our constants are together. So 10 equals 10z. Oh, I really love that. Holden, what's our answer?
1.
Z equals 1. How do we get 1? We can divide both sides by 10. Well, why didn't you tell me that earlier?
I feel like I'll get in trouble.
Yeah.
Why would you ever get in trouble for that?
I get in trouble for the most random thing, Joey.
Yeah.
Joey, no.
Okay, so thank you, Colin, for paying attention. 7 minus 17 is definitely a negative 10. And when we divide by negative 10, our answer is totally a negative 1. Guess what? Things are like that are going to happen. They're going to happen to you. They're going to happen to me. You need to not be afraid to say, Mrs. Holman, I think it's like this. Because you know what? I did that on purpose to see where we are. Now I know where you stand. You guys were the one. I don't feel like I am a scary person. Am I, Colin?
No, you're right. You're like
But apparently I'm very intimidating. We can't. Okay. Does somebody raise their hand over here? Elliot. I do not want a straw. Why do you have straws? All right, we're gonna do number 4. And I bet when you were looking at this page, you were hoping that I did not do number 4, but we're doing number 4. Hey, 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 hey. Hey, hey, hey. Here we go. Let's decide the first thing we need to do. Estelle. We cannot do that because we have these parentheses. We need to take care of those first. So Sam, what do we need to do? Nope, nope, can't do that. We cannot take 48 minus 16x because 1 is a constant and 1 has a variable, okay? Avery, instead, what should we do? We need to distribute, okay? So I just made it smaller. No big deal. Okay, so we're going to take this 3/4 and we are going to distribute it in to our parentheses. Now, you probably don't like multiplying by 3/4, especially when our numbers are big. But remember, 3/4 times 48 means we're multiplying by 3 and dividing by 4. So let's do this. If you don't have a calculator, we can still do this in our head. We can take 48 divided by 4, which is 12, and multiply by 3 to get 36. Minus 3/4 times 16x. Well, I think it's 12. Because 16 divided by 4 would be 4. And then we have the multiplied by 3 would be 12. You okay with?
I'm just acknowledging the minus sign.
But it would be minus. You are right. Yep. Okay. Now, I will let you use calculators on this. So it's totally fine to be using a calculator. Okay. Now, I don't think we need a calculator over here. We need to distribute this 4 through. So we have 4 times 4. And then we have 4 times 8x. Okay. Here again, I'm just the kind of gal that I really like my variables to be positive. So if I were making the decisions, which I am, I'm going to add the 12x to both sides. But if you want to subtract 8x to both sides, you do you, and I'll do me. Okay. So I'm going to add 12x to both sides to get 36 equals 16. Ooh, plus 20x.
That's a nice number.
That is a nice number. Okay, Colin, help me out.
So you minus 16 to both sides, and then you divide it by, then it should equal 20.
We have 20.
Yeah.
20
divided by
equals
20.
20x.
Yeah, 20 divided by 20 equals 1x.
Golden isn't one. It might be.
Okay, do you remember when I said we should always know if we're right? Okay, let's do that. We have 3/4 times 48 minus 16 times 1. Okay, what's 48 minus 16? 32. So we have 32 times 3/4. 24. Okay, does that equal 4 times 4 plus 2 times 1? Woohoo! Okay. Okay. All right. What's confusing? Okay. Next, I would like you to move to number 5. Requires 0 noise. Okay. Aiden, what do you think the first thing we need to do would be? We need to combine like terms. So this is what I'd like for you to do. You combine like terms and then solve for Q. Do it without my assistance. Go. I have no problem if you talk to your elbow partner.
What? What?
Oh, yeah.
I did that wrong.
Oh,
I did that wrong.
yeah, I don't know how.
Yeah. So don't.
There's 2 negatives and positive.
In what context?
If you're well, because you would add this.
So -2 plus -6 is -8.
Okay.
Because we have -2 and we keep going more negative.
What would I do?
So we have 3Q, right?
Yeah.
So, oh, how'd you get 8Q? What is that? So that's an equal sign.
Oh, yeah.
So you need to add 2Q and Q together first before you can move it over to the other side. Okay. I don't remember.
That's what I got.
Check in with your elbow partner if you haven't already. You're gonna fall. Somebody already did yesterday. Put them on all fours.
Falling is fun.
Me and someone else.
I think so.
Yeah.
You haven't even done what I asked you to do.
I don't back ring. Wow.
Okay. You need to take 2Q and Q and add them together first. And then like we did up here, we need to get Q's on one side and non-Q's on the other side. Okay, so do the first step, combine like terms over here. What's your question? So 2Q plus Q is 3Q.
Yes.
Yeah.
So on the right
Precisely.
side, you need to write 3Q minus 2.
Okay.
No.
Team effort.
Okay, let's talk about this together.
So I did something wrong.
Where did the 8Q come from?
Were you supposed to?
So 2Q plus Q is 3Q. Do you agree? So if you have 3Q and we would subtract 5Q over, this would turn into a negative 2. So it's not 8, it's negative. Okay, does that make sense? Okay.
I know.
Okay, we'll go through it. Okay, the first step of your equation. Look up here, the first step of your equation. You need to take 2Q and Q and add them together. Okay. Now, some of you subtracted 3Q to both sides. Some of you did the other way. So I'm going to have 2Q plus 6 equals negative 2. If you did the other way, you would have 6 equals negative 2Q minus 2. Either way is fine. Okay. If you subtracted the 3Q over, then we would need to subtract 6 to get 2Q equals negative 8, so that Q equals negative 4. Okay. If you instead subtracted the 5Q, then you would add 2 to both sides, and you would have 8 equals negative 2Q, and still Q equals negative 4. Okay. Okay, so look at this work right here. Raise your hand if you have a question.
Close enough, not mad and math.
Voices, voices, voices. Maddie, you okay with that?
Yeah.
Did you find where you made a mistake? Okay. Okay, no, not everybody got to negative 4. That's okay. We're gonna make mistakes. What is important? What is important, Nirvan? What is important is that we figure out where the mistake happened and we correct it. If you got this wrong and you totally just tuned me out up here, that's not helping. Okay? If you got it wrong and you followed along up here and you changed things to look like my work, that's helpful. That's what we need to be doing. Okay? We're going to do one more problem before we look at the special solutions. I want to look at number 10. This requires 0 noise.
How come we don't do every problem?
Because we don't have time for that. Okay. In this problem, I see parentheses involving lots of numbers. We need to distribute so that we can combine like terms. But the reason I wanted to do this problem in class is because this 3x minus 8 parentheses 2x plus 3. Okay, so the 3x stays as the 3x, but this minus 8 needs to get distributed through the parentheses. So what is negative 8 times 2x? Negative 16x. And then we have this minus 8 times a positive 3. Gives us negative 24. Okay. Now we also have this negative 6 to distribute through. Okay. We have negative 6 times 2x. And we have negative 6 times 5. Okay. So first of all, before I go any further, is everybody okay with our left side being 3x minus 16x minus 24? What's wrong?
I just don't like it.
Okay, fair enough.
That's a
Okay.
valid reason.
You're stretching. Okay. So do we have like terms that we can combine? Yeah. We sure do. Over here, we have 3x. We have 3x minus 16x. Negative 13x. Well, we have 3x minus 16x. So now, ooh, I really like this. I see that I have a minus 13x on the left side, a minus 12x on the right side. So I think I'm going to add 13x to both sides because that's going to alleviate one step for us. Because look, I have 1x minus 30. Yes. I have 3x minus 16x. Okay, so now we can add 30 to both sides to get 6. Are you okay, Cohen?
Yeah, I will.
Okay. All right, in your homework, you will get some more practice at problems that need to use the distribution property, combining like terms, isolating the variable, okay? And we're gonna, I don't know why we are acting like that. I need you to turn back to page 14. Okay. So equations don't always have only one solution. Most of the time they do. 90% of the time they will.
What about that?
Okay. Sometimes we could have infinitely many solutions. I don't like this. Okay. When we get an equation that is true for all values, we have infinitely many solutions. On the other side of things, we could have an equation that is not true for any value, which would result in no solution. Okay, I'm going to explain what that means. But basically what this is saying is it's possible to have one solution. It is possible to have no solution. Yeah. And it is possible to have infinite solutions. Okay, and how do we know when we have each case? That's what we're going to work on for the last bit of class. We'll figure it out. We will figure it out with the process. Okay, so if we have one solution, then what's happening is we get an answer.
Really?
X equals 5, X equals 753, X equals negative pi, whatever it is, you're going to get an answer. Okay. Now, what about no solution? Okay. No solution means no value for X is ever going to work. There is nothing we can plug in for X to make it work. When that is the case, you're gonna get some weird statement. Is 0 equal to 7? Like never. It's not. I'm sorry that you feel that way. Make it look like a 0 for you, okay? 0 equals 7, 24 equals -3. If you get a number equals a number, but the two numbers aren't the same, and all of your X's have disappeared, if you get an untrue result, we don't have a solution. There is nothing you can plug in for X to make that thing true. Okay?
Oh, so you
Yeah.
Will you tell us though?
You're gonna have to figure it out. But what's nice about these, and I'll show you, I always show you. What's nice about these is that the X's will go away. All right. And same thing with infinite solutions. Okay. The X's are gonna disappear, but you're gonna get a true statement. How often is 6 equal to 6?
Always.
All the time. No matter which value I plug in for X, there's not an X to plug into anymore. Okay, no matter what value we plug in, 6 is always 6. So we can plug in. We have an infinite number of solutions for our equation. Okay, would you like to see examples of each of those? All right, we are going to look at number 11 and number 12 on page 16. Okay, that is how we're going to finish off our lesson. Okay, so we're going to look at number 11. You know, we can use any letter we want. If you want to make it X, I have no problem. For this particular example, but don't do it on a quiz or a test for me, okay? Okay. On all fours. I need you on all fours. On all. No, you're not.
No, I do not see.
Nathan,
Why are you arguing with the teacher?
It's pretty.
all
sus.
fours.
I'll give you 77 cents if we don't have the finish.
Right.
No.
Right.
Okay. The first thing we need to do in this equation. Kane, what do you think? What is the first thing we need to do? We need to distribute. Oh, and we got to do it twice. So let's distribute the 6 through first. We have 24S plus 6 times 12.
72.
You sure it's 72? Okay.
It is 72.
60. Very good. All right, now get excited. Look, we are, oh, you really did. Okay, we're gonna distribute the 8. Oh my gosh, we have 24S minus, Estelle did our calculations for us. 8 times 14 is 112. Okay, so now I want to get my S's together. So I'm going to take this 24S and I'm going to subtract it to the other side. My voice is getting really tired of talking over you. I'm going to subtract 24 to both sides. What just happened?
No, 24.
The 24 S's are gone on both sides. And we get 72 equals negative 112. Okay.
How do you know?
Abby, how many times is 72 equal to negative 112? Never. It is never true. So we have no solution. Your answer is no solution. Guys, we just cut our workload like in half. We're done. We have no solution. Hey, voices off, voices off. Okay. Are you okay with why it's no solution? Okay, Avery, are you good with why it's no solution? Yes. Okay, our variables, there's poof, gone. The variables went away and we have a number equals a number and it's never true. Never true, so we don't have a solution. All right, let's look over at number 12. I'm curious what happens in number 12. So, we know over here. Okay. Hey, this will go a lot faster if you're just quiet. Just listen. Okay. Now, my left side, there is nothing that I can do to simplify on the left side, but is there something we can do on the right side?
Yeah.
Okay, we can distribute. So I have 16F plus 24 equals 16F.
Low key, that looked the same.
Hey, so look at this. I'm excited because I have 16F on both sides. And I know that if I subtract 16F to the other side, what? They cancel and I'm left with, okay, Colin, how often is 24 equal to 24? All the time. So we have infinitely many solutions. What's your question, Sophia? Do you see an X that we can solve for? Or an F?
Why is it called infinite? Because it's just only.
Okay, she has a very good question, and I need to explain this a little further for you. I will wait for you to be quiet. Okay, she asked, why is it infinitely many solutions? This is 24 equals 24. What this is saying is we could plug any number in for F, and it's going to be a true statement. So you know how up here we got Q equals -4. And if we plug -4 in for Q, it works. But if we were going to plug in 5 for Q, it would not work. If we were to plug in 17 for Q, it would not work. The only number that works when we plug it back in is -4. Now, when we get this situation of infinitely many solutions, I could plug in any real number to F in this case, and I would get a true statement. Do you want to try it?
No.
We don't got that time.
Like if I plug in 1, 16 times 1 plus 24, does that equal 8 times 2 times 1 plus 3? Okay, I don't know why A, anybody is packing up, or B, why you're making any noise. Just hold on. We would get 16 plus 24, we would get 40 equals 40, okay? If I were to plug in like -2, okay? I would get -32 plus 24 is, I think, -12. Nope. It's -8. It's 8. It's -8. And then over here I get -8. Okay. Any number I plug in for F is going to work because we have infinitely many solutions. Okay, Sam.
So infinite, you can't get infinite.
So infinity is a concept. It keeps going and going and going and going and going. Hey, where's your homework at? Okay, we're on day 4. We are on day 4. No. I'll have you do Map Accelerator, but